Greetings everybody to example 3 of vectors. So what we're given in this problem is that a plane is flying at a bearing of north 43 degrees east, and it's flying at a speed or magnitude of 550 miles per hour. The wind then comes in at a magnitude of 25 miles per hour from the southwest at a bearing of north 15 degrees east. And so the question is, what is going to be the new bearing of the airplane once we take into account the wind pushing on, or the wind influencing the new resultant velocity vector for the airplane? So let's see what we can do to actually go and solve this problem. So to begin, if we kind of slide our velocity vector for the wind up to the end of the velocity vector for the airplane, then we're going to get something that basically looks like this. So that our resultant vector is just going to have a value that's really doing something like this. So now the question is, how do we find the bearing for our angle theta for this new vector? Well, it takes a little bit to do, but if we can find the angle between these two vectors, then we can find some of the angles for our triangle, and just using some law of sines and law of cosines, we're able to do that. So let's jump in and see how we can make that happen. So to begin, let's add in the vertical that we have for our two vectors. Now, if we then extend our plane's velocity vector to kind of head off into that direction, we know that the angle between the vertical and our plane's velocity vector is going to be 43 degrees. Likewise, we know the angle in between the vertical and our wind vector is going to be 15 degrees. So kind of what happens then in this case is that if we look at the complement of our 43 degrees for our plane's velocity vector, then that's going to give us a value of 137 degrees. So now with that value of 137 degrees, we can add this to our angle of 15 degrees and to give us an angle between our velocity vector for the plane and our wind vector. So if we do that, then the angle between what we then have for, if I can put this one in here, there. So our angle between our wind vector and our velocity vector is just going to be the sum of the 137 and the 15 degrees. And so we have a value of 152 degrees. So now if we kind of put in our resultant vector, what we find is a picture that looks something like this. So then we are able to use our law of cosines to then find the magnitude of our resultant vector. And so for that, we have that it will just be our square root of 550 squared plus 25 squared minus 2 times 550 times 25 times the cosine of the angle between those two, which is 152 degrees, being the complement of our 43 plus our angle 15 degrees for our wind vector. And so this is actually going to give us that the magnitude of our resultant is going to be approximately 572.1940744. So now kind of turning to the angles that we're interested in. So we want to know our angle theta between the vertical and our resultant vector. Well, in this triangle, since we know the value of the opposite side, we know the value of an angle, and we could use our law of sines to find the value for the angle phi. And so from our law of sines, we know that the sine of phi divided by the length of the opposite side, 25, is going to be equal to the sine of 152 degrees divided by the magnitude of our resultant, so our 572.1940744. So this is going to tell us that our phi is going to be approximately the arc sine of 25 times the sine of 152 degrees divided by 572.1940744. So this gives us a value of phi that's going to be approximately 1.175327.871 degrees. So now the relationship that we can have for our angle theta that we want, theta is then going to be our 43 degrees minus our value of phi. And so for that, we have approximately 41.82467213 degrees. So I hope you've enjoyed this example, and I will see you guys in the next problem. Take care.